to my channel Siddhanath Nishanda. I first welcome to the second year students. Just entered in now mechanical stream. Now onwards the journey starts in the mechanical stream. Myself Ashwin Nishanda. I'm assistant professor at mechanical department. Have 8 years of teaching experience. I'm pursuing PhD at Shiva University Kolhapur. I have published two books in Wiley and Lambert. Also, I provisionally filed two patents and more than 12 papers I have published in reputed journals, peer-reviewed journals. Okay, I'm going to cover the thermodynamics throughout this semester. I'm deals with the thermodynamics. Okay, now the first chapter is our first law of thermodynamics. Okay, before going to the first law of thermodynamics, you must know the some fundamental concepts. Okay, in today's lecture, I'm going to cover what is meant by thermodynamic systems. So let's start with the thermodynamic systems. Okay, thermodynamic system, lecture 1. Okay, now what is meant by thermodynamics? Okay. Okay, thermodynamics is the science of energy and entropy. Okay, now what is meant by entropy? We're going to discuss in the further chapters. Okay, in today's lecture we just focus the thermodynamics is the also is called as the science of energy, science of motion. The word thermodynamics is derived from Greek word. Okay, if you divide the words a therm and dynamics, okay, the meaning of therm, that is the energy, and the meaning of dynamics, we know it is the motion, it is the power, it is the transport. So thermodynamics is nothing but the heat power, or also called as the energy transport. And there is a more important thing, it is the relationship between heat work and forms of energy. So thermodynamics is called as the generally science of energy, science of motion, and always correlate the relation between heat work and forms of energy. In this slide we see the different applications of thermal engineering. Okay, there is the we see surrounding, there is the refrigerator. Okay, then is the compressor. If you see the internal combustion engines, gas turbines, satellites, they are the different domains of the thermal engineering. They are the different applications of the thermal engineering, and these all are the applications as showing in the figure. These are the systems we call as the thermodynamic systems. Okay, then how it is defined in further slides we're going to cover. Just to focus there the applications, and the main purpose of this today's lecture, you have to identify which system is open, which system is closed, which system is isolated. Okay, and this thermodynamic system is divided into two parts. Okay, just in first lecture I am going to cover the fundamental definitions and the concepts, and the second lecture part 2 we have to apply these thermodynamic systems. Okay, let's start with some fundamental definitions. If you see from the 12th standard, we see there is the such type of diagrams. There is one circle, or is called as a system. But the number of systems students fails to apply this what is the system surrounding boundary to the actual applications. Just I start with the definition of system. Okay, the system is the particular region or area or space where some thermodynamic activity takes place. Okay, if you take a particular region from the universe under study, is also called as a system. Everything outside the system is called as a surrounding, and the system and surrounding, if you see the system and surrounding is the separated by the system boundary. Okay, now just these definitions we apply through this example. We take the piston cylinder arrangement is enclosed with the gas. Okay, in this case if you see the system is act as a inside surface area of the cylinder, which is coated with, or it is equipped with the gas, is act as the system. Okay, everything outside of the system, if you see, the outside area of the cylinder is called as a surrounding, and the system and the surrounding is separated by the system boundary. If you see here, the boundaries act as the inside surface area of the cylinder. Okay, and the system includes the whole volume along with that gas is act as a system. Why it is called as a particular area or region? Because where some thermodynamic activity going to takes place. Okay, what is the thermodynamic activity? If I applying force on the piston, what happen? The volume goes on decreases, and if you add heat in the cylinder, what happen? The gas starts to expand and the piston moves in the upward direction. So by addition of heat or by applying work, there is some thermodynamic activity going to start in the system, and this activity happen because I have developed or designed such a area. Okay, so it is, the word is very important, the particular area or region where some thermodynamic activity going to takes place. Okay, if we see, there are two types of boundaries. Okay, maybe boundary is fixed, real, maybe boundary imaginary. Okay, then boundaries again classified in different group, different types. Okay, we can discuss in further slides. Now just we remember or going to conclude the again these definitions. System, a particular area or region where some thermodynamic activity going to takes place. If you see this inside cylinder area where thermodynamic activity going to takes place means when applying force, okay, and when we supplying heat, there is the interaction between Q and W. When applying W, what happen? The gas going to compress and it releases heat to the surrounding, and with supplying heat, what happen? The gas going to expand and it gives W. So there is a transformation of energy according to thermodynamic system or according to thermodynamics. I told in the definition there is a relation between heat and work. Like that, we have to just understood outside area of the cylinders act as a surrounding. Okay, now the very important terms, the types of boundaries. Okay, if you see in that example, the boundary is movable. Okay, if you're going to compress this gas, this boundary going to decreases. Okay, okay, when applying force, what happen? The system boundary goes on decreases. Okay, and when I'm supplying heat, that system boundary goes on increases. So such type of boundaries called as movable boundaries. Now if you see the further slides, what is meant by imaginary boundaries? Okay, and the real boundaries. In previous example, we see this is the real boundaries. Okay, now the imaginary boundaries, what happen in case of suppose IC engine? Okay, during the exhaust stroke, the gases is going to release to the atmosphere. Okay, and that gas boundary is spread to the atmosphere. So it is very difficult to trace that boundaries. So such that boundaries is called as a imaginary boundary. If we also studied in the fluid mechanics, if we take for the derivation the particular area or the particular cross section of that pipe, okay, so that inlet area and the outlet area of the pipe is we also call as the imaginary boundaries. Hope you understood the fundamentals definitions, what is the system, surrounding, system boundaries, fixed boundary and the real boundaries. Okay, before going to the starts, the types of thermodynamic system, we just recall the concept of thermal equilibrium. Okay, what is my thermal equilibrium? No change with respect to temperature, no temperature gradient. What it indicates? If you see the hot cup of tea or coffee of with respect to time, what happened? It releases heat to the surrounding, and after a certain interval of time, that temperature of that coffee or the tea at the temperature is same as the surrounding temperature. If you see the cold drink warms up with respect to time. Okay, if we put the cold drink in the surrounding, what happened? It releases heat to the surrounding. Okay, or the surrounding heat is goes to that cold drink. We know that the heat is always from a higher body to the lower body temperature. So the surrounding heat is warms this cold drink up to that temperature becomes in equilibrium. So the when body is brought in contact with the another body at temperature difference, heat is transferred from the body at higher temperature to that with the lower one till both the attain a thermal equilibrium. Okay, now starts with the main part of the today's lecture, that is the thermodynamics systems. Okay, the thermodynamic system is classified generally closed system, open system and isolated system. But actually the three systems mainly classified in two groups: control mass and the control volume. Okay, into next lecture, if you understood what is the actual concept of control mass and control volume. In today's lecture we just focus on these actual definitions, what is a closed system, isolated system and open system. If we see, there is one symbolic representation of the systems. If you see the exchange of matter with the surrounding, which is indicated by blue arrow, and the exchange of energy with the surroundings indicated by the red arrow. Okay, in case of isolated system, if you observe, there is no arrows. What it indicates? It indicates there is no exchange of matter, there is no exchange of energy. So such system is called as a isolated system. Okay, if in case of closed system we see that red arrow, there is only exchange of energy, there is no exchange of matter, that is the closed system. And in case of open system, there is exchange of energy, this red arrow, and that blue arrow indicates there is exchange of matter. And if you see that arrow is crosses the boundary of the system. So I again going to conclude the definitions. In open system, there is exchange of energy as well as matter or mass across the boundary of the system is called as open system. In closed system, there is exchange of energy takes place. There is no exchange of mass across the boundary of the system. There is only energy. That is a closed system. And there is no exchange of energy. There is no exchange of matter. There is no exchange of mass. Is called as a isolated system. They are the very important. Okay, just keep the examples. Day-to-day life, I have put some examples. If you observe in surrounding, okay, in closed system, if you see, there is only transformation of energies. Okay, this shows one pot or the one pressure cooker is covered with the plate. What indicates if you heat them, there is only energy is transferred via radiation, via conduction. Okay, but there is no transformation of mass takes place because this that chamber or that pot is closed with the plate. So there is no takes place, there is no evaporation. So it opposes the evaporation. So there is no transformation of mass. There is only transformation of energy. If you remove the plate, what happens? There is the evaporation is going on. So the mass, some mass is releases to the surrounding. Okay, if you remove this plate, what happens? The system is converted into now open system. Okay, and there is one another example is the thermos flask. If you see, the thermos flask is the best example of the isolated system. If we keep the cold drink or the hot coffee, is remains same temperature because this system and surroundings is separated by the some vacuums, some evacuated tubes, maybe some glass wools, okay, which protects or to lose its heat to the surrounding. This thermos flask is the best example of the isolated system. There is no exchange of energy, no exchange of matter, so it is called as the isolated system. Hopes you understood the fundamental concepts of thermodynamic systems, thermal equilibrium and the definitions. Okay, next lecture we are going to apply these systems further applications.